In this video, I am going to introduce a new chapter of chemistry, that is atomic structure. It is also called a structure of an atom. So first I want to introduce what is an atom. As you know that atom is the smallest part of a matter, and this atom word has been taken from Greek word atomio. It means uncuttable or non-divisible. So we can see that atom cannot be divisible into smaller part. All these ideas were mere speculation because there was no way to test them experimentally. In the year 1808, a British teacher named John Dalton proposed atomic theory of matter, which is known as Dalton's atomic theory. According to Dalton's atomic theory, atom is the smallest part of the matter which cannot be divisible into smaller parts. Second point, all the atoms of an element are identical, whereas atom of one element is different from atom of another element. And all the atoms of an element have identical property including atomic mass. Third point, when we prepare compound, then atoms of different elements combine in a fixed ratio to produce compound. For example, water. So to produce water, we take hydrogen and oxygen, and they are taken in a ratio of 2:1. And then the last point, in a chemical reaction, restructuring of an atom takes place. It means atom cannot be created. Atom can neither be created nor be destroyed. It can be only rearranged to produce a chemical compound. But studies in the 20th century prove that atom itself divisible into even smaller particles known as fundamental particles or subatomic particles. These fundamental particles are electron, proton and neutron. So first I will categorize electron, proton and neutron on the basis of the following properties. So first, name of fundamental particle, symbol. What is their symbol? Charge. Charge in coulomb. Mass in AMU. AMU is the atomic mass unit. Mass in kg. And its position. Very important. So first is the electron. Its symbol is or E minus. Charge is -1 unit. Its charge in coulomb 1.6 into 10 to the power -19. Its mass in AMU 0. Mass in kg. Its position outside nucleus in the orbit. Second, proton. It is P or it is +1 unit. It is 1.6 into 10 to the power -19. It is also 1 It is 1.67 in 10 to the power minus 27 kg in the nucleus. Third is neutron. It is N. No charge. Mass 1 mu. 1.67 into 10 to the power minus 27 kg in the nucleus. So here one thing I want to say, this is 0 and this is 1, minus 1, because this charge we write here, atomic number is here, mass number is here. This will be plus 1 here, this is not this. Now it's okay. So these are the comparison between electron, proton, neutron. Electron is a negatively charged body, proton is a positively charged body, whereas neutron is a chargeless body. If we compare the charge, then in Coulomb its charge of electron and charge of proton both are equal. The difference is that electron has a negative charge, whereas proton has a positive charge. Whereas mass of electron and protons are different because electron is lighter than proton, and the position is very, very important. That all the fundamental particles, if we compare fundamental particles, then an atom has two parts. First part is its nucleus. This is the nucleus, and outside the nucleus there is an imaginary circular part. This circular part is called orbit, and this part is called a nucleus. So here in the nucleus, proton and neutrons are present, whereas outside the nucleus, electrons are present. So I have mentioned outside the nucleus in the orbit, whereas proton present in the nucleus, neutron present in the nucleus. Now how will we arrange electron in the orbit? That I will discuss as I will continue the class later on the class. Second things, now I am going to start molecule. Very, very important point. Molecule, whenever we are going to categorize molecules, define molecules, two things we have to keep in mind. First, whether we are going to discuss molecule of an element or molecule of a compound. When we are going to discuss molecule of an element, then we can define it is combination of two or more than two similar atoms. Whereas when we are going to define molecules of a compound, then we can say it is combination of two or more than two different atoms in a fixed ratio. For example, H2, hydrogen H2, it is a molecule of an element, whereas H2O is a molecule of a compound. So we can say that molecule of element is combination of two or more than two similar atoms, whereas molecule of compound is two or more than two different atoms with a fixed ratio. So as we are discussing about molecules, so there is a one term that is very, very important. We should know it, that is atomicity. What is atomicity? It is the number of atoms combined to produce molecule. That is called atomicity. So molecule of an element can be classified into three types. First, monoatomic, second, diatomic, and third, triatomic. One more classification, that is polyatomic. Monoatomic, there are some elements like helium, neon, argon, they exist independently. So they exist in a monoatomic form. Their atomicity is 1. But hydrogen, oxygen, nitrogen, chlorine, they are not present independently in the nature. They combine, they present in the diatomic form to produce H2, N2, O2, Cl. Ozone, that is O3. Here, three different atoms combine to produce a molecule. So it is a triatomic molecule. Whereas phosphorus, P4, sulfur, acid, here 4 atoms of phosphorus and 8 atoms of sulfur combines to produce polyatomic molecule. So in this way, we can categorize molecule of an element. So we can say that molecule of elements are the following types. First, monoatomic. You can take example of helium, neon, argon. Diatomic. You can take example of N2, H2, O2. Their stable form is N2, H2, O2. So we can say that N is not possible. Nitrogen N is not present in the nature. N always present in the form of N2. Oxygen always present in the form of molecular form, and its molecular form is diatomic form. Third is triatomic. Triatomic, that is O3. And the last one is polyatomic. Very, very important part. Polyatomic, and this polyatomic part is P4S8. So in this way we can categorize, we can explain atomicity of an atom. Now, if we want to discuss molecule of a compound, here I am using second part C6H12O6. This is a molecule of a compound, whereas these are molecule of an element. So molecule of compound are produced by different atoms, and there is a ratio. This is 1:2:2. Whenever we are going to discuss molecule of a compound, then it is important to know that once compound is produced, the identity of the atom is lost. What I want to say? Suppose iron, it is a magnetic in nature. Sulfur, non-magnetic. But when we combine iron and sulfur to produce iron sulfide, or you can say ferrous sulfide, so it is non-magnetic in nature. The magnetic property of iron disappears. So once a compound is produced, its properties of the various atoms are lost. So these are the classification of the molecules. Now I will explain radicals and ion. Radicals are group of different atoms which behaves as a single unit with either positive or negative charge. Here I want to take one example. Now I will make difference between radicals or ion. Radicals, ion is a atom having positive or negative charge. You can say ions are categorized into two parts, cation or anion. Cations are positively charged atom or anions are negatively charged atom. But radicals are group of different atoms which behaves as a single unit with either positive or negative charge. Suppose here this is ion and this is radical. So we can say that ion is either positive or negative. The positive ions are known as cation, whereas negative ions are known as anion. An atom turns to positive ion when it loses electron. That is, loss of electron produce cation, whereas when an atom gains one electron, it turns to anion. Here, one thing I want to add, that when we convert atom to cation, then electron will decrease. Very, very important point. Decrease of electron. So we can say that here sodium has 11 electron, sodium has 11 proton. Here electron of sodium is 10, whereas proton of sodium is 11. No change in proton. It is the electron that will either increase or decrease. So while formation of cation, there will be increase of electron. Here, when we are going to produce an ion, there is an increase of electrons. This is very important point. Increase of electrons. So we can say that Cl atom electron is 17. Its proton is also 17. Now Cl minus ion electron is 17 plus 1. As many charges, that many electrons will increase. So it will be 18 and proton again it will remain same, that is 17. Now radicals are two types. First, what is radicals? So we can say that group of atoms having positive or negative charge. So there are two types of radicals. First is the basic radicals and second is the acidic radicals. So we can say NH4 plus ion, ammonium ion. It is a basic radicals, whereas nitrate ion, it is a acidic radicals. So all the cations are called basic radicals and all the anions are called acidic radicals. Now there is a question, how will give the naming of ions or radicals? So whenever we are going to name of an atom or ion, suppose Cl, it is called chloride. It is called chlorine. But when we convert into minus ion, it is called chloride. So to convert an atom into an ion, we add a letter I. IDE in the name of the. But suppose if we take Na, so it is a sodium. When we turn Na plus, it turns to sodium ion. There will be no change in cation, calcium ion. But to form an ion, we add I. So for radicals, this is nitrate. So we can use word AT. This is nitrite. So we can say ITE. And this is sulfide. So it is ID. So we can say that whenever we have to convert or whenever we have to pronounce radicals, either we use ate, ite or ite. So in this way, we can categorize, we can classify what is ions or radical or how will we give its name. Now the next topic that we need to explain, that is very important part, is valency. Valency is the combining capacity of an element, or we can say it is the bond making capacity of an element. So sodium chloride, magnesium chloride. Suppose if I say sodium react with chlorine to produce sodium chloride. Here, what is the formula of sodium chloride? It depends upon valency of sodium and chlorine. Magnesium chloride, valency of magnesium and chlorine. So all these information related with valency I will explain in detail, and I will going to prepare an organized table in which elements are arranged and how we pronounce its valency and how we make formula of that compound. This is very important part that is going to be used whenever we are going to make formula of a compound, especially for standard 6, 7, 8, 9, 10, that is a basic class, and its application is going to be used in standard 11 and 12. So I will make an organized table, and on this basis, I will explain how can we find valency. Is there any trick regarding that? We will discuss in detail. So to explain the process of valency or what definition of valency, we need to know some terms that are going to be very important. First is the atomic number. Atomic number is the number of proton present in an atom or number of electron present in an atom. For example, if atomic number of sodium is 11, it means it has 11 electron or 11 proton. It is always written like this. Suppose sodium. So its symbol is Z. Whereas here another words we use, that is A, it is a mass number. So Z is the atomic number and this is called mass number. Mass number is the number of proton and number of neutron. So when we are going to discuss topic or concept related with valency, we need to focus atomic number of an element. So I am going to prepare a table, and on this table I will show how to find valency of a given element. So I am going to write 20 elements, that is the basic part of chemistry. So here I am going to write symbols H, He, Li, Be, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. These are the 20 elements. Very important. This is the background or the basic part through which we continue, and once you have command on this part, you can easily find valency, valence electron, formula of a given compound. So this is a symbolic representation of a given element. Second part is atomic number. So here atomic number, hydrogen 1, helium 2, lithium here 3, then 4, then 5, this is an ascending form, 6, 7, 8, 9, here 10, here 11, 12, 13, 14, 15, 16, 17, then 18 and the last 19 and the last is 20. So these are the atomic number. Next part that is going to be important whenever we are going to arrange elements, electron, proton or neutron in an atom. Electronic configuration. Electronic configuration. So what is electronic configuration? You can see that electronic configuration is the arrangement of electron in the given orbit or shell. How will we arrange electrons in the given orbit? It can be explained with the help of electronic configuration. So for the juniors, that is still standard 10, we use different orbits like K, L, M, N or 1, 2, 3, 4 to divide electron, and for the seniors we will discuss S, P, D, F. In terms of S, P, D, F, that I will teach you in the next video, but in this video I will arrange electron on the basis of either shell, K element or orbit 1, 2, 3, 4. So here I am writing shell is the K, L, M, N. So for first electron, here 1, 2, 2, 1, 2, 2, 2, 3, So this way we can write the electronic configuration of different elements. So now how will we study? In the first orbit, we can put maximum 2 electrons. Very, very important for us. Suppose if you are going to arrange for sodium, so first orbit, it is fixed that how many electrons you can put? It is 2. Now, in the second orbit, we can keep maximum 8 electrons. After that, if we have more electrons, then we jump with the third orbit. So sodium has 11 electrons and 11 protons. So first we write 2 here. 8 is the next orbit, because in the second orbit we can put maximum 8 electrons, and the third orbit is again 1. So here maximum electron in the first orbit is 2, maximum electron in the second orbit is 8, maximum electron in the third orbit is also 8. For potassium, argon, arbitrate, and whatever electron left, it is the last orbit. So here I am showing electronic configuration of the elements up to atomic number 20 that we use for the junior class, or we can say that till standard 10. And for the senior section, that is 11-12, we use different concepts, categorized, or we use different techniques to arrange electron, that is SPDF configuration. Now next point is the valence electron. Valence electron is the electron present in the outermost orbit or shell. If I say, what is valence electron of lithium? You can say it is 1. This is the outermost electron present in the orbit or shell. But for hydrogen, its valence electron is 1. It is outer or inner, both are same. But for lithium, outermost is 1. For sodium, outermost is 1. So valence electron is the number of electrons present in the outermost orbit, and valence electron is one of the most important terms that helps us to know group number and valency of a given element. Here, one trick I want to give you, this is important. Valence electron, that is used till standard 10, and group number. Group number I will discuss later when I will teach you periodic table. If valence electron is 1, group number is 1. If valence electron is 2, group number is 2. If valence electron is 3, then we add 10. So group number will become 30. 4, group number becomes 4, that is 14. 5, group number becomes 15. 6, group number becomes 16. 7, group number becomes 70. And 8, that is group number becomes 80. There is only one exception, that is helium is an exception. Over there, valence electron is 2, but its group is 18, it is an inert gas element. So valence electron plays an important role to find group number or to find where is the position of the element in the given periodic table. Valence electron also tells valency, that is combining capacity of an element. It is very, very important point that why do atom react? An atom reacts to fulfill either duplet or octet configuration. This is duplet. We use for light element, and octet we use for heavy elements. This is the requirement of an element. Either it will fulfill 2 electrons or 8 electrons in its outermost orbit. You can take example of sodium. Its atomic number is 11, so we can say 281. If sodium transfer loses its 1 electron to other elements, then its octet will be completed and it will develop to Na+1. So we can say that valency of sodium is 1, because valency is the number of electrons lost or gained by an element to fulfill its octet or duplet configuration. So magnesium, it's 12. So we can say 282. So if magnesium transfers its 2 electrons, then it will also complete its octet configuration, and after transferring 2 electrons, it will develop two positive charge. So number of charge present on an atom is the number of electron transferred or given by one atom to another atom to fulfill its octet or duplet configuration. Whereas number of negative charge indicates number of electron taken by an element to complete its octet or duplet configuration. Chlorine, it is 17. So we can say 287. So here it will take one electron, and after taking one electron it turns to Cl minus ion. So we can say valency is the bond making capacity, or we can say the number of electron transferred or taken by one atom to another atom to fulfill its octet or duplet configuration. So here we can use another trick for valence electron and valency. If valence electron is 1, valency is 1. If valence electron is 2, valency is 2. If it is 3, it is also 3. But if the valence electron is 4, we can say 4 minus 8, it is minus 4. If it is 5, 5 minus 8, it is minus 3. If it is 6, then 6 minus 8, it is minus 2. If it is 7, we can say 7 minus 8, it is minus 1. And 8 minus 8 is equal to 0. So here we see that some valencies are positive, they are metal. Some valencies are negative, they are non-metal. And the element, if the elements are showing zero valency, it is inert. It is zero gas elements or inert gas. So here we will fulfill the concept. For hydrogen is an exception, its valency is 0. Sorry. Helium is an exception, its valency is 0, hydrogen is 1, lithium is 1, beryllium is 2, boron is 3, here 4 minus 8, that is minus 4, here 5 minus 8, that is minus 3, here 6 minus 8, that is minus 2, here 7 minus 8, that is minus 1, here 8 minus 8, that is 0. Again here 1, 2, 3, no change. 4 minus 8, it is minus 4. 5 minus 8, it is minus 3. 6 minus 8, it is minus 2. 7 minus 8, it is minus 1. 8 minus 8, it is 0. Again 1, again 2. So these are the concepts through which we can write valency. So valency depends upon valence electron. Once we have idea of valence electron, we can make valency also. Now, next part of this is some elements are showing variable valency. Variable valency, for example, iron, it has +2 valency or +3 valency. So those elements which are showing more than one valency, they are called variable valency showing elements. Normally, we get for the transition elements, d-block metals, we use variable valency concept. So using this table, I am going to prepare the formula of a compound that is the backbone of chemistry. Because in the previous video I have already explained what is chemistry. So chemistry is the branch of physical science in which we study formula, we study equation. So unless we have a strong formula, we have a concept of making formula, we cannot go ahead chemistry. We cannot understand chemistry properly. So for the crisscross formula, to make formula, we need two things. First is the symbol, and second is the valence. These 2 points are very, very important. Suppose you want to make formula of sodium oxide. So we need sodium, symbol is Na, oxide, that is oxygen, from oxygen oxide has come. So it is O. Valency of sodium here, valency of oxygen 2. From the table I have explained. Now we will exchange this valency. That's why it is called crisscross. To make the formula, it will be Na2. One thing I want to remind you, or explain that whenever we are going to make formula, so negative or positive sign of valency are not important. You just keep the numbers. 1, 2, minus 2 is not important, plus 1, minus 3, this is not important. Second, suppose aluminum chloride. Suppose you want to make formula of aluminum chloride. For aluminum is Al, for chlorine is Cl. Its valency is 3, its valency is 1. So we exchange it. So formula will be AlCH. Now we can take magnesium oxide. This is important. Why? I will explain. Magnesium oxide. It is Mg. This is O. Its valency is 2. Its valency is also 2. Common. So we can say Mg. If the same valency are there, we can cancel it. If different valency are there, we will cross it to make formula. So here in sodium oxide, one thing remember, this 2 represent valency of oxygen and this sodium 1 represent valency of sodium also. Because in higher classes or another subject, if we want to break, we need to break this part. So it is important to note that here Na will develop positive charge and oxygen will develop 2 negative charge. This 2 is the for oxygen and this 1 is the for the sodium, and as there are 2 sodium atoms, so here I write 2. Very important part. Suppose you want to break aluminum chloride. This part we will study in higher classes electrolysis chapters where we are going to ionize or dissociate a given compound. Here aluminum chloride will break. It is Al3 plus because this valency is for aluminum and chlorine is 1. For Cl we write minus 1. And as 3 Cls are there, so we can write 3 Cl minus. Magnesium oxide we have to be very careful because magnesium valency is 2, oxygen valency is also 2, so we cannot write Mg plus 1. This is wrong. Here we have to be careful that magnesium valency is plus 2 and oxygen valency is also minus 2. This is very important. Now, for radicals, how to make formula? Suppose we want to make formula of sodium carbonate. Sodium carbonate. Radical list has been given in different books. You have to memorize their symbols. For sodium we write Na and for carbonate we write CO3. Its valency is 1 and its valency is 2. So formula will be Na2CO3. This is sodium carbonate. Suppose we have to write aluminum carbonate. Aluminium carbonate. So again we write aluminum is Al, carbonate is CO3. So aluminum is valency is 3, its valency is 2. So its formula will be Al2CO3 whole 2. CO3 whole. In this way, we can make formula of the radicals. So, now I will give some questions and how to solve this question one by one we will discuss in this part. So, using all these concepts, we can solve a number of questions. We can discuss a number of questions. So, I am giving some questions one by one. So I am giving some questions first. What is difference between H and H2? 2H and 2H2. Na plus and Cl minus. H2 and H2O. CO3 2 minus and Cl minus. So first I will discuss all these 5 questions. Here H is the, we can say, one atom of hydrogen. This is important because when we are going to solve question based on mole concept, we need to explain this. We need to know this, that what is H? This is one atom of hydrogen. And this is one molecule of hydrogen. This is two atoms of hydrogen. And this is two molecules of hydrogen. Na plus, you can say it is a cation, or you can say it is an ion. Here, number of electron is less than number of proton. Cl minus, it is an anion. It is a type of ion. Here, number of electron is more than number of proton. H2, you can say it is molecule of an element. This is molecule of an element. This is molecule of a compound. This is called molecule of compound. What is difference between molecule of an element and molecule of compound? Molecule of element will show the property of its atom, but molecule of compound will not show its property of an atom. Once compound is produced, the property of atom will be disturbed, it will be destroyed. Here, it is a radical of carbonate. You can say carbonate radical. Or you can say that it is a acidic radical. Very important point. All anions are acidic radical, whereas all cations are basic radicals. This is known as anion, or you can simply say ion. So these questions are very important to improve your concept related with questions based on atomic structure, language of chemistry and other chapters. Now I am giving some more questions. Here Cl minus is an ion, Na plus is a cation. Here positive ion is called basic radical. So what is basic radical? All cations, radicals with positive charge are called basic radicals, where radicals with negative charge are called acidic radicals. So in the next video, I will explain some more questions based on atomic structure, and I will explain in detail the other parts of this chapter. Thank you.